Question 3. A physics teacher demonstrated dispersion for her class. She asked students to draw a diagram of the dispersion. The diagram shows 4 examples of what different students drew. One of them is correct. Which one? Okay, dispersion. Dispersion experiment. The formation of the rainbow. Okay, we have a glass prism here. Oh wow, it's a real thing. A glass prism put on the path of a light ray from the sun. Like the light from the sun get through a window, okay, forming a beam like this, and this glass prism is placed here, and it will refract the light, this light beam, and separate different colors, forming a spectrum like this, like a rainbow. As it is the evidence that the beam of here, normally I show this in this experiment. This is the beam of light from this is the get just a filter. Do that later. This is just a red filter, which means it only allows the red color to pass through it and block all other colors. The green, the blue, they all block. Okay, only the red color passes through this filter. But I want to show the experiment with no filter. Okay, here. This is the white light. The color is white, okay, from a light source that can emit the light very similar to the sun. Normally, many schools has that device, not very expensive, cheap device that can emit this kind of light, like the normal light bulb in your room right now. If it is like the white color, not the yellow color, okay, because I know many houses use the yellow color at night. Yes. This white light actually is a combination of a lot of color, million different colors, okay? Yes. And different colors when passing through another medium, which is not the air. For example, this glass, a transparent but denser medium compared to the air. Different color will have different speed in that medium. The red color travel faster than the green color and faster than the blue color in this medium glass, okay? And therefore different color are refracted at different angle when passing through this prism. Let me show a picture of that thing, dispersion. Okay. Dispersion. Yeah. So when a beam of the white light consisting of different color, various color, okay, enters a glass prism, different color, red, orange, yellow, etc., are refracted at different angles. The red color are less refracted, while the blue and the violet colors are refracted at a greater angle, because the blue and the violet travel at lower speed compared to the red color and the yellow color, okay? The faster the speed of a color, which is a type of light, different color of light are different because of the different wavelength. The wavelength, we really learn the wave, huh? The concept of wave, and we have 2 types of wave: longitudinal wave and transverse wave. And light wave, I will explain to you later about the nature of light wave. Imagine it is a transverse wave, like this. Actually, a light wave is an electromagnetic wave consisting 2 components, varying electric field and also a changing magnetic field. But imagine this is a light wave, okay? The distance between the two successive crests of the wave is the wavelength lambda. Wavelength. Okay?
Yeah.
And different color has different wavelength. For example, the red color has the wavelength about 700 nanometer, which means it is extremely short, 1,000 times shorter than a millimeter. Okay, meaning we, of course, we cannot see those waves. We only see the color when light hit an object, like an apple. We see the red color on the apple. So different wavelength has different velocity, different speed in the medium, the glass or water medium. Okay, and therefore they are different color, refracted at different angle, and it forms a spectrum, a rainbow, after passing through the prism. And this phenomenon is called dispersion. Okay, dispersion. You should remember that the white light, the violet color are refracted at greater angle compared to the direction of the incident light. This is the incident direction, okay? And the violet color are refracted at greater angle compared to that incident angle, while the red color are refracted at a smaller angle compared to the incident direction, okay? Red less refracted, and the violet refracted more. The violet travel with lower speed, more slowly, lower speed in that medium, the glass medium, okay? And the red color travel at higher speed, higher speed. So the answer to this question, one of them is correct among the 4 students. Okay, observe these diagrams carefully and tell me which one is correct. Compared to the diagram that you've seen, for example, this one. So the correct answer is,
I think D. Wait, no. That's not. Oh wait, is that a D or D? Oh wait, what's the difference?
In B, the refraction occur here on the opposite side of this incident side, opposite side at the bottom here, and here it's happened on the left side. But which one is correct? Compared to this thing, it started.
Oh, okay.
Wait. It is like opposite, huh? In the experiment, in the question, the line start from above, like this, not from the bottom, huh?
Yes.
So, okay, you need to compare the direction of the incident ray with the direction of the refracted ray. The point is like this. Firstly, you need to draw a normal line to the surface. This is the surface. Here, the normal line, which is perpendicular to the surface. Normal line. Wait. Oops. Okay, this normal line to the surface, perpendicular to the surface. The refracted ray must be on the other side, on the right side of the normal line compared to the incident ray. The incident ray is on the left of the normal line, and the refracted ray is on the right of the normal line. Okay. So return to this. We draw a normal line here. Okay, it is fine, meaning that it is on the other side also. This is one side on the ray, is another side. Okay. Yeah. And here we also draw a normal line. Yeah, on other side, right side, left side. It is correct for this one, I think. How about this one? When you draw a normal line, which is like this, let me zoom in 300%. Nevertheless, you see that they are still on the different side, right? Where all like perpendicular. Wait. It looks like this thing is perpendicular to the line, the surface. And when a ray is perpendicular to the first surface like this, they are not dispersed, meaning it is only one direction going straight. They are not refracted when entering a medium at a right angle like this. So this thing is wrong. Okay. Let me try finding an experiment showing that if the light is perpendicular to the surface, it is not refracted, okay, but going straight. I haven't seen one because I didn't look for that case, but hopefully, okay. Light ray perpendicular to a surface. Refraction. Laser perpendicular. Light refraction. Perpendicular. Experiment. Refraction. Okay. In glass prism. Okay, hopefully this one can show that thing. Okay, here. When you see, when the light ray here is perpendicular to the boundary between the glass block and the air, the external surrounding in the air, okay, we have a circular, half circular block here. And when this light ray is perpendicular to this boundary, this surface, you see, it travels straight. The light ray goes straight without being bent, okay, without refraction.
Yeah.
Okay, that's the interesting thing. About the explanation of refraction, I don't remember that I told you about it, but okay, I can repeat it. Here, when the light rays goes to the surface at a certain angle, this angle between the incident ray and the normal light is called incident angle. Okay, incident angle, and this is the refracted angle. The reason for this phenomenon, refraction, is because different light rays, different light waves in this ray, this single ray, it's not actually one ray. We can call it the beam, okay, a beam of light. And in this beam, there are actually a lot of waves, billion waves in that parallel beam, okay. Think about this one, refraction explanation. Refraction car, okay, here. The car tie, I'm looking for that picture. Similar to this one. Okay, here. Open image. This is a toy car, but it's similar with a real car. We have the two medium, the pavement, like concrete, okay, and the sun region. The car travels in this direction, passing through the boundary between the pavement and the sun. This wheel, this front wheel, okay, enters the sun region first, and this wheel is slowed down because the sun has greater resistance, okay, greater friction. So this wheel is slowed down. When other wheels, the two back wheel here and the other wheel on the other side here, still travel at the old velocity, faster velocity, and this single wheel, which enters the sound region first, is slowed down, having lower velocity, and therefore the car is refracted in this direction. This wheel travel a shorter distance, and these two wheels travel at faster, longer distance. Okay, and therefore the car is turned in this direction. It's similar to light. When a beam of light here going from the air to the water region, water medium. Okay, actually in this beam of light there are 1,000 or even trillion rays, and some rays are slowed down first, and some rays take some tiny time, but a moment anyway. The other rays are not slowed down yet, and therefore the wave change the direction. That's the refraction. Okay, similar to the refraction of a car.
Yeah.
Okay, so when the light ray enter the water region at a perpendicular angle, all the waves, all the components having the same velocity, and all of them slow down at the same rate. They travel at the same rate, and therefore they go straight without bending. Okay.
Yeah.
In this experiment here, going straight, the light goes straight when it is perpendicular to the surface, the boundary here. Okay. So for this diagram, this light ray travel perpendicularly toward the surface, and therefore it goes straight to the other side, not refracted, not dispersed like this. Okay, so answer D, option D is wrong, and the correct answer is B.